Okay, so you are doing FPGA IP, so I believe this is to put FPGA cells on system on chip, but what is the typical application of your technology?
Well, the typical application is really depending on the customer, and the customers that we work with do not always share their final application, and some of them even are really secret about it.
Sure.
So I would say that one typical application is secrecy.
Yeah.
Because having an embedded FPGA part of SoC, it allows you to tape out a chip at any foundry, leaving one part of your chip unknown to everyone because it doesn't have a function. It only has a function when the chip comes back to you and you program it. And this I would call one of the applications.
Oh, okay. Okay. So can it be used for specialized DSP algorithms, encryption, for like all this sort of stuff? So
yeah, in general, everything that is already associated with FPGAs, all common use cases of FPGAs, they're also transferable to an embedded FPGA on a SoC. Except that you have to remember that when you are inside an ASIC, you have ASIC gates.
Yes.
You have the possibility to already do a lot of very smart and efficient things. So when you're inside an ASIC, the FPGA, the matrix, it should really be limited to the generic logic that is very difficult to predict. Because a DSP is something that is, it's rather known.
Yes, it's better to put blocks to the actual ASIC and put into a FPGA some secret know-how you don't want to share.
For instance, a state machine. You have all the blocks in your ASIC, but you need a state machine to make them work together and actually perform an operation, process data. If you put the state machine into an FPGA matrix, it's not part of your chip. Someone can steal your chip and they won't be able to do anything with it.
But how do cells in your FPGA compare with Xilinx and Altera cells?
So it depends how much area the customer is willing to allocate to the FPGA. You have to have in mind that an FPGA is a really big circuit. Because for every logic function, you need many logic functions. And you also need logic functions to do the routing. As a result, the area ratio between an fixed ASIC gate and an FPGA is rather big.
This I know, but how similar the cells to structure of Xilinx and Altera cells? Is it something very different or same principles?
It's not very different. To be honest, in the technology-independent version of the IP, where there is no need to do any custom circuit design, the performance will be a little bit lower because you use standard cells. But this comes at the low cost of the IP. Then, of course, if what you want to do,
let's repeat.
When you want to do a small Xilinx competitor, you can go to the extent of doing some custom circuit design, and in that case, it will be apple and apple.
Yes. Yeah. Okay. This is very interesting. Thank you.